Hello, my name is Kilgore and this is my prime factors kata. So first I'm going to start by creating a new SpecklJ project called prime factors, and then I'm going to open it up in IDEA. Now let's just get my files together. I'm going to open up my source file and my spec file. I'm going to separate them so that I can see them both while I'm running my environment. And then next, I'm going to delete all existing code just so that I have a fresh slate. Now let's open up my console and we're going to run our test file. As you can see, there's no failing tests because we don't have any existing test or production code. So let's get our describe ready and let's just describe prime factors. And the context is going to be that we are going to give a list of prime factors by returning. And then that will depend based off of our specific use cases. So in our first one, if we give it a prime number, then it should just return the given input. So I'm going to get this set up. So for example, it should just return 2 if we give our prime factors function 2. We're going to run this and we're going to get a compilation error. This is because obviously prime factors does not exist in our production code. So now that we have a failing test, we're going to create that function and we're going to run it and it will pass. Great. Now we can move on to our next method, or our next test, which will be 3, which should return 3, which fails, so we're going to refactor again. And then it passes. Great. Now we're done with this case. Next, it should return an empty vector if we give it a number less than 2. This is because all numbers less than 2 don't have any valid prime factors. So it should return an empty vector if we input 1. So we're going to enter that and it's going to fail. So we're going to refactor. We're going to say that if n is less than 2, we'll return an empty vector. Otherwise, we'll just return the input. And it passes. Great. So now we're done with this case. We're going to move on. And we're going to say, if we're given a list of prime factors, it'll return a list of prime factors if given a valid non-prime number. So here, if we give it 4, for example, it should return 2, 2, because those are the 2 prime factors of 4. And that fails, so we're going to have to refactor our code a little bit. So in this case, we're just going to change our else statement to define a variable. We're going to let a variable factor, and it's just going to be the first value of all potential factors, of all potential prime factors of a given number. Once we've set this number up, it will conjoin that value with a recursive call of prime factors such that we are chopping that factor off of n in the next recursive call. If we save that, our test passed. Great. Now let's just run a few more tests just to make sure it's running properly. So 9 should be 3, 3, that works. And then 500 should be 5, 5, 5, 2, 2. So let's run that. And it passes. Great. Now, looking back at our main production code, you can see that this function's a bit long, and we could take some of this out. So we're going to create a helper function, and we're going to call it getFirstPrimeFactor. And all it's going to do is it's just going to take this existing code, and we're going to slap that in there. And we know it already works from our previous tests, so we won't have to test this. And we will just put that into our function, and then save it again just to make sure it runs, and it does. Great. So now we're going to do one more test case, and this is a situation where what if we have our answer is 2 repeating a certain amount of times. So for example, if our expected answer is 2 repeat 10 times, then does our code work properly? In this case, it does. Great. Now let's try 100. That works. 1,000. That works. 10,000. Uh-oh, now we have an issue. Now, the issue we've run into is that we've blown the stack. So in order to fix this problem, we're going to have to do some tail recursion such that we don't blow our stack. We don't have a stack overflow error, if you will. In order to do this, once we call prime factors with a single number, we're just going to call it again, but with an empty list as well. And then in this, it will essentially do the same thing, except it will tail recurse, and we will cons factor onto factors being our accumulating list of prime factors of that number. And then n will update the same way as it did before, such that we're just chopping factor off of it until n gets smaller and smaller. And then we'll run that, and it passes. Great. And I could do this for bigger numbers, but it will take a really long time to compile, so I'll save you that issue. And now we're just going to clean up our code a little bit. We're going to make it look a little nicer. We're going to clean up our tests as well, because they should be treated just as well as our production code is treated. And it all works. Great. So we're going to close that up. And we're going to delete our kata. And we're going to clear our terminal. Thank you.